lesson so that we can have reference with the time to come. Now, previously, we looked at the reflection of light, and we are looking at reflection of light on curved mirrors. Curved mirrors, they are of two types. We have the convex mirror, which is known as the diverging mirror, and we also have the concave mirror, which is called the converging mirror. We have other mirrors that fall under concave mirrors, and those are what we call the parabolic mirrors, but we shall see their nature. How are they different from the usual concave mirror that we know? We looked at how the image can be formed, or we looked at the image formation when an object is placed at different points along the principal axis. When the image is placed at point F, which is the principal focus, what is the nature of the image in case we are using a concave mirror? We looked at that. We looked at if the image is placed in between the principal focus and the pole of the mirror, what's the nature of the image? Do you remember very well, members, those kind of things that we looked at last time? Do you remember, Mary?
Yes, teacher.
Okay, I know Stephen, you also attended that lesson. Ndamira Baptist, I think this is your first lesson of physics, paper 2, but you should follow up the videos which are already on the website. All you need to do is to first log in, and then you go to resources, videos, then you look for videos of reflection of light by Senior 5. Now, today, this is what we are going to look at. So allow me to share you this screen of mine. So today we are looking at that. So these are some of the mirrors. We shall see these mirrors, their importances. So these are some of the importances of those curved mirrors. We shall see them. We shall also be able to observe this. These are telescopes, and also to see this. What does this? We have ever seen this somewhere? For example, one picture here, like this one, you have ever seen. So we shall see what we are dealing with. But for now, allow me and I take you to our class, virtual class. So now, last time we looked at all these things, and we looked at the formation of the image when the object is placed along the principal axis, and this is the nature of the image. So go through the video and you have a recap of what we did last time. Now we are the first thing that appears on our notes there is what we call the uses of concave mirrors, uses of concave mirrors. So there are quite very many uses of concave mirrors, but we can see the first one is it can be used as a shaving what? Shaving mirror. Shaving mirror. You know what a shaving mirror is, members? Have you ever used let me ask you this question. Have you ever used a shaving mirror? For example, if you want to, let me ask Stephen, you are the one with beards. Have you ever used a shaving mirror? Sometimes students ask, we don't know what you are talking about. Even we don't know what a shaving mirror is. So let me first show you what a shaving mirror is, and then you understand what we are talking about. We don't know. Have you seen a shaving mirror? You people unmute so that we hear one another.
Yes.
Yes, unmute, unmute, Narubega, unmute, 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 unmute. So that's a shaving mirror. So a shaving mirror is curved. It is curved in that way, such that we can see a magnified image. Even this gentleman who's here, this is a curved mirror. This is a curved mirror and it is a shaving mirror. So shaving mirrors are normally curved. If you have not bought one, please get one, and then you see, you touch, and you feel it. So let us go back to our notes. So that is a shaving mirror. It is used as shaving mirror. It is also used, concave mirror is used as, concave mirror too is used as dentists, used by dentists, used by dentists, dentists for tooth examination. Tooth examination. You can get tooth decay and even you cry tears, members. You should know that tooth decay is not a joke. If you get a tooth decay, you may cry tears, but curved mirrors are used. Curved mirrors are used by dentists to examine the tooth. Curved mirrors by, let me say, by dentists. Dentists. And you see, okay, now you can see how those curved mirrors are. Some of you have never gone to the dentist like me. I've never gone to the dentist because me, I don't suffer from tooth problems, those tooth problems. But someone there whom I know who's online, I don't want to mention the name, just me eating popcorns and then starts to cry. So these are the curved mirrors. You can see this is a curved mirror. And you can see that now the tooth is magnified. Here it is magnified. So the person is able to observe or to examine the tooth. So to do that, how are curved mirrors or how are concave mirrors used to examine the tooth or to examine any tooth decay problem? So the object, which is the tooth this time, is placed between the focal point and the pole of that mirror such that a magnified image is observed. So previously, when we were looking at that, this is the kind of scenario that we're looking at when we were drawing that kind of ray diagram. So this ray diagram, which I'm using here on my notes, is what we consider when we place an object between F and P. So the tooth or the teeth is placed between F and P of this mirror such that now the image that is formed is virtual, it is erect, and it is magnified. So it is virtual, it is inside that mirror. It is formed behind that mirror. It is inside. You can see it is inside that mirror, and it is virtual. It is virtual. That's why it is inside. It is erect. It is erect. It is up. It is not upside down, but it is upright, and it is magnified. So that kind of nature, or that kind of property of being magnified is one of the reasons why they use a concave mirror as a mirror used to examine the tooth by these professions, the dentists. Okay, so we go to the next part there. The next part here under our importances is one, they're used as solar concentrators. So we have solar concentrators. So write solar, used as solar concentrators. Solar concentrators. What are solar concentrators? What are solar concentrators? So I've just showed you what solar concentrators. So these are solar concentrators here. For instance, if I use this image, which is here, you can see that a solar concentrator is made in a way that it will trap all the light from the sun, and the light is made to is focused at one point, and that one point is what we call the focal point. So at the focal point, they place a secondary mirror such that all the light beam is is reflected into this kind of system which is here, and then we can receive it. Under this receiver here. So solar concentrators, there are very many types of solar concentrators. You can have this picture here and see. These are solar concentrators also from the sun. So even solar panels, these solar panels that we have that are used to generate electricity, they are made in a such a way that some of them are concave. They have those kind of the photocells or the glasses are made in a way that they are concave in order to trap that light, such that that light is focused at one point. Now we have solar concentrators in Uganda. If you don't know where they are, let me show you. They are in Tororo, and one day you will get there. So this is part of the solar concentrator in Soroti. It is in Soroti, part of the solar concentrator plant in Soroti. This one here, as you are seeing. So one day you go and visit and see how those solar concentrators are, but this is how they are. Their main purpose is to generate electricity, but through the sun rays. All right. So now you have traveled around the country in just 1 second, isn't it? You see, there is no lockdown now. Okay. So let us go back and we see our notes. The other thing is that they are used in reflecting telescopes. So we shall go back and write that and say used in reflecting telescopes, used in reflecting telescopes. And I also showed you reflecting telescopes, how they look like. So these are the reflecting telescopes. These ones here, these are the reflecting telescopes. So what is inside that reflecting telescope? If I may show you this one here, you may see clearly that inside this telescope there is a mirror. We have this primary mirror which is here, and in this primary mirror you can see it is concave, but just in between it there is a hole here. So it is concave, and we have also another secondary mirror. So this one is also, this is a plain mirror, but this is concave. So you can see the concave mirrors, they are found in reflecting telescopes. Later on we shall see what reflecting telescopes are. I think we have one here at school. When you come back, you'll be able to see it, and also to view maybe the sun, or you want to see Mars, or you want to see other planets. We have this one here at school. This one here, we have it here at school. So you just get ready, just make your eyes ready, and then when you come, you'll be able to watch whatever you want to see, maybe at night. Or so those are reflecting telescopes. So they have got reflecting mirrors, and those mirrors are concave. Members, are we together?
Yes.
Yes.
Very good. So we go to the next thing. Number 5. They are used in projectors. Used in what? Used in projectors. So you may see what I want to see what I'm writing. Used in projectors. Used in projectors. A projector is a device that for showing slides on the screen. So what happens is that I know some of you are just begging, are just saying, now I wish he shows us what a projector is. Okay, projector. Okay, so let us go inside. Oh, this is so dangerous. So inside there is a mirror. I'm looking for a nice picture to show you here, but so they have shown us inside a projector, and this is what I was looking for. So all these things are sophisticated. But please, if you have a projector, don't dismantle. Don't dismantle. I know Naruvega now you are very, your interest has increased so much. Don't dismantle. But I failed to say a good image to show you. Let me see, maybe something here. So a projector has got a mirror inside, and okay, maybe one day we shall, when you go to Google, try and search about projectors, you'll be able to see the mirror there. So the projector has got a reflecting mirror, and that mirror is concave, and that mirror, its purpose is used to focus all the light onto the slide. So normally it is at the back, and it is at the back of the lamp. So there is a lamp inside, and there is a mirror. So if this is the lamp here, there is a concave mirror at the back here, and here we have a slide here. So the light which comes from the mirror has to, from the lamp, has to go through the slide, but this other light that comes from this side, it is reflected back to the same path, such that it goes back onto the slide. So here is the lamp, and the mirror is placed at the back, but that mirror which is placed at the back is a concave mirror. And then here we shall have what we call the condenser, something here. Condenser has got it has two lenses there. So that's what you studied. You studied something similar to that in your O-level about projectors. And we shall look at projectors when you reach the optical instruments, Very good. Now, the other thing that you should know is that the advantage of concave mirrors is that concave mirrors forms magnified and also erect image. So that's the example of a concave mirror. Yes, it produces, or it forms magnified and erect image, concave mirrors. So a concave mirror will form a magnified image, and the image which is erect when the object is placed between the focal point and the pole of the mirror. So you should know that the object must be here in between F and P, for you to have. Let me zoom in there, and you see very well. The object must be between F and P so that you have a magnified image. And that's when concave mirrors are used as magnifying mirrors, or are used as magnifying glass. Okay. Now, images formed by a convex mirror. Now, a convex mirror will form an image that is erect, that is virtual, and that is diminished in size, no matter where the object is placed. Even if you place the object near the pole, even if the object is just here near the pole, or is the image that will be formed will be diminished, will be erect, and it will be virtual. If you place the object far away from the pole, still you get the same result. So how would you draw this kind of diagram when you're looking at images formed by a convex mirror? What's the nature of the image formed by a convex mirror? So you should draw that. So the first thing you have to do is to draw your you have to draw the principal axis, PA, principal axis, then put a straight line there. Okay, put the straight line here. Then afterwards, indicate that you are drawing a what? You are using indicate that you are using a convex mirror, like that. Then what we know is that for a convex mirror, the focal point and also the center of curvature, they are virtual. So they are inside the mirror. So if I take a centimeters, so that means that at this point here, I can put the focal point here, then I can put the C there. So this is F and this is C. So they are inside the mirror. And then you can place, first this is the pole, you can place the object at any point. So let us place the object here and then see what we get just here. For us to have a difference with what is in the notes, let us place it here. That is the object. So remember that there are three rays. There's the first ray, which is always parallel to the principal axis. This ray always parallel to the principal axis and comes from the top of the object. All rays come from the top of the object. All rays come from the top of the object. Now that ray that is parallel to the principal axis after reflection will be diverged, but it appears as if it comes from the principal focus. So something like that. Okay. And then the other ray comes from the top of the object to the center of curvature. And this ray is reflected back through the same path. So if the ray is this one, and this is the center of curvature, as the ray comes like that, because the ray is incident on the mirror at an angle of 90 degrees or normal to the mirror, so it means that it will not change the direction, so it will be reflected through the same path. So it appears as if it's coming from the center of curvature and it is reflected back through the same path. Come on. Like that. So here it is going and then it is reflected back. So at that point where they meet, I can zoom in there very well and you see at that point where they meet, at this point where the two virtual lines meet, at that point, that's where we have the image. And the image that is going to be formed is virtual. So we shall use dotted lines to show that the image formed is virtual. That. So this is the image. So no matter where the object is placed, always the image that is formed is virtual. It is upright. It is virtual. It is upright or it is erect, and it is diminished. Someone is saying no, it is diminished. Okay. All right. So let us proceed. So they are saying that in addition to providing erect image, convex mirrors have got the wide field of view as illustrated below. So convex mirrors have a wide field of view as we can see here. So this is the reason why convex mirrors are used as driving mirrors. They're used as driving mirrors or side mirrors. What is the driving mirror and the side mirror? What is the driving mirror and side mirror? John Baptist, do you know a side mirror? Now, John Baptist, how can
Yes.
do you know a side mirror?
No.
You don't know a side mirror? Okay, good. I never know. Do you know a side mirror? Can you differentiate a side mirror and a driving mirror? Okay, we've had.
Teacher, the side mirrors are these ones which are on the side of the car, and the driving mirror is this one which is in front.
The one which is in front. Okay, the one which is in front. So let us see driving mirrors and side mirrors here. Sandra, good afternoon.
Good afternoon.
Okay, so we have the side mirrors. These are side mirrors. This is side mirror, and this is a driving mirror. This one is a driving mirror. This is a driving mirror. This one. Are you driving in rear view mirror? So
the one found inside is the driving mirror.
Yes, this one here. Giving rear view. This one here. And this one is a side mirror. So you can see all mirrors. This one is a convex mirror. You can see how it is curved. It is a convex mirror. And then also this one here is a convex mirror. There you cannot see it how it is curved, Let me try and see if I can get one which is carved very well. Maybe this one here can show how it is carved. You see that kind of nature which is there. It is carved. So it is carved, and that is a convex mirror, or it is a diverging mirror. So that's how those mirrors look like. Okay, 10 minutes. We go back to our notes and see. So because it produces, because this mirror forms an erect image, and also it forms a virtual image. So you should know that this mirror also has a wide field of view, and because of having a wide field of view and being able to form erect images, that is why it is used as a driving mirror or as a side mirror. Now here in our notes, we have the kind of diagram that is drawn for you to explain how this kind of convex mirror is used or gives a wide field of view. So they are saying that in most cases, a convex mirror will always produce, will always form, the word is form, not produce, will always form a virtual image. But what you should know is that also a convex mirror can form a real image. When does it form a real image? So they are saying that a convex mirror can form real images if it receives converging rays targeting any point between the focal point and its optical and its pole. This should be pole, and its pole, like in the above case. So they are saying that if there are converging rays that are coming from that are targeting a point that is in between the focal point between F and P, then the kind of image that we are going to have will be a real image. So if the screen was to be placed at the position of the eye above the real image, there above a real image would be formed. So here what they are saying is that, if I may zoom in there in that diagram very well, I may not draw this diagram, but you practice how to draw it. So they are showing that this is the field of view. This one here, this part here. So if someone is seated here or has placed the eye here, so this person is able to see something far because the mirror has got a wide field of view. So if we are to place a screen where the eyes are here at this point here, we are likely to have a real image at this point here. And then what you have to know is that all these objects which are far this other end will be observed, because the mirror, because of its nature of being curved, gives a wide field of view. Also, the images that will be observed through this mirror are going to be erect images. They're going to be erect images, or they are going to be upright images. So this takes us to the uses of convex mirrors, that they are used as driving mirrors. This is because they always form erect images and have a wide field of view. The other one is they are used in supermarkets to observe activities of customers. That one, I will not Google it. I think you have already seen that, members. I think most of you have even worked in supermarkets. Naruvega, where do you work these days? Damira, I think for you you work somewhere, maybe in a supermarket. So in supermarkets, you have those giant mirrors. They are always placed there to observe the activities of the customers. They are also used in security checkpoints to inspect under the vehicles. You have already seen when those gentlemen are checking under the vehicles, they always show those, they always want to see what is inside. So can say mirrors used for security checks. Okay, this kind of mirrors, you have seen these mirrors here, this kind of mirror here. So these mirrors are, you can see how it is curved. So they are convex, mirrors. So under the vehicle, to observe what is there. Why? Because the mirror in supermarkets, this is how the mirror looks like in supermarkets, because the mirror is concave. So you can even see what is this side or what is even this other side at this end, because the mirror gives a wide field of view. Are we together? Okay. Members, are we together?
Yes.
Some of you are feasting on your lunch and you have not invited me. But anyway, let us proceed. Let us look at the advantages of convex mirrors over plane mirrors. So the other advantage that you should know is that the convex mirrors have a wide field of view. That is the first advantage, and also they form erect images. So when they ask you, can you explain the advantage of convex mirrors over plane mirrors, draw the diagrams and give the reason to why, and you say that plane mirrors are used as driving mirror. I mean, convex mirrors are used as driving mirrors, or are used as side mirrors because they have a wide field of view and they form erect images. While plane mirrors, so you must have drawn these two diagrams, and so while plane mirrors have a narrow field of view, they have a narrow field of what? A narrow field of view, and that's why they are not used as car driving mirrors or car side mirrors. The disadvantage of convex mirrors. Who can give me one disadvantage of convex mirrors? One disadvantage of convex mirrors in these next 3 minutes, before we go to derivation of the relationship between radius of curvature and the focal length. So give me one disadvantage of convex mirrors that you know. Yes, let me start with Sandra. Sandra, give me one disadvantage.
Diminished images.
Okay, disadvantages of convex mirrors. Sandra,
Yes.
are you fine? You sound
I've said it formed.
You sound too low.
I said it forms diminished images.
Okay, good. It forms
Diminished images.
Diminished images. Then the other one is then the other one is okay. Forms diminished images or gives wrong impression to drivers. That is that the object behind is very far. So because you have already seen when I drew my diagram there, this one here, you can see where the image is here. Here the object is near. And also in this diagram that we have for our notes, the object is far. So you can see the image is always between F and P. Are you seeing that? The image is always between F and what? F and P. F and P. So as the person is driving, the image appears, the object will appear as if it is very far, yet the object is near. Or the object will appear as if it is near, yet it is very far. So it gives a wrong impression of the driver, like how we saw in this kind of where is it? Driving mirrors. I think I've just removed it. But where we saw how these driving mirrors give wrong impression. Let me show you. So you can see in this side mirror, we don't know where this car is. It appears as if it is far, yet it may be near. So such a thing like that is a wrong impression. So someone may cause an accident, but when an accident is coming from these kind of mirrors. So that's why sometimes these border men, someone is driving and the border man is coming. Some may think the border man is very far, yet the man is very near, and they collide with one another. So in the next session,